pretty much the same thing. Okay, so we started this topic. Let us go over this.
Sir, one more thing. I see that the homework are coming due
After the vacation. You want me to? The problem is then all the deadlines 2-3 will be right, at right next to your midterm too. Do you want me to do that? I can do that. So it's your call. Actually, this week you had 1 or 2 deadlines. This week. Then there was one student who said, "Can you postpone it?" So I postponed it to vacation. Don't worry.
okay, sir. What we can do? Just postpone it to later part of the vacation on Thursday, Friday. I see there's a homework due on Tuesday.
Okay.
So we have a need.
So from this Tuesday, let me
move on to
Sunday.
Thursday, Friday, or Sunday.
Okay, I will do it. Yeah, no problem. Okay, so the question we have is this one. The question says that we have this door lock mechanism. This 14 kilogram is the mass of a collar. And you have this motor. What happens is that this motor provides a constant torque, subsequently a constant force. So it pulls like T. So this is a complete door mechanism. Okay, are you getting my point? So because of this, and you see this 14 kilogram, this is the main portion of the door mechanism. You can say that holds the door. When you switch on the motor, so this 14 kilogram moves towards right. You are smiling. Actually, this whole T thing I intentionally do just so that everyone has a practical idea of the problem. Anyways, okay, so that's fine. So 14 kilogram moves. This column moves towards right. Now you can see that there is a spring, right? Now, when you are providing a constant force, eventually the force of the spring with which it is pulling this 14 kg will keep on increasing. Now, what happens is that there is this mass balance that is hanging here as well. You can call it a counterbalance. So just understand that the motor pulls this gate, main component of the gate, towards right. Then what happens is that along with it, there is a string that is connected to this point. So when this moves towards right, this also moves towards right. Subsequently, there is this counterbalance that also goes down, I suppose. Now, I understand that you are wondering why on earth do we have a counterbalance? This is what I'm about to tell you. This counterbalance along with this spring, all of them combine together, and our purpose is that when someone switches the motor on, then this collar keeps on going. And when eventually it arrives right at this point, it automatically should stop, because the spring force, along with the counterbalance, along with the fact that when this weight moves up or down, there is a friction force of 180 Newton because of the walls as well. So everything combines together. You switch on the motor, it goes like, and eventually the velocity goes zero right when the 14 kilogram, the fellow that holds the gate. So it's like opening, closing gate mechanism, you can say. Switch on the button, and then the collar stops right next to this point 2. So my point 1 is 14 is here. My state 2 is when this collar arrives here. You don't want this to crash into this, right? So you really want it to stop. Questions? Now, last time I told you, if you're attending this class the first time, you did not attend last time, you can still join us the moment I write the formula. But the point is, you cannot apply F equal to ma here, because acceleration here is also a function of position. It is a complicated problem because spring force keeps on changing. Okay, you have to make this diagram if you can, by the way, roughly. If you don't, then I will continue. Do you want me to continue? Continue. Okay. So what is the first step? For those of you who attended the last class, I'm happy. If you did not, you can join us by the formula. The formula says that you have to write the work energy principle, U, then you will write, where are my notes? 1, 2, then you will write O for outside, you will write NC for non-conservative, then you will write delta T. I hope the screen is shared. Screen, okay. Delta T, plus we have delta VG plus, let me, should I change the lighting?
No, it's cool.
Good, okay. Delta VG plus delta VE, okay. So please, I keep on repeating, you have to remember outside non-conservative, U12 equal to these three things. Now U12 is work done by non-conservative forces or other outside forces. So there are two components to it. One component is the work done by motor, right? Because motor is the one that is pulling it with 60 Newton. The other chunk is
They work done by companies.
the friction, friction, I would say. That's why the word F here. If these walls had been smooth, then no friction, and I would not have put any term. So that's why I did not use the word work done by counterweight. I do not want to use that wording because I will emphasize why. Look, if there was no friction, then this counterweight would have gone up and down, right? So you have to be very clear that when something goes up and down, that is a change in gravitational potential energy, and gravitational potential energy term appears here. So work done due to height change, that's conservative, right? Because I take this mobile to here, or I take this mobile from here to here, as long as I'm talking about work done due to gravitational force, it is independent of path. So that's why I will be very careful in the wording that external and non-conservative are only the two fellows. So equal to, I will not do it. All of you will do it. Okay, do it. Is it easy? So just so that everyone is with us, what is change in kinetic energy? What?
Change in the, I was asking what is change in delta T?
Change in kinetic energy. Okay, now the distance is 0.4 meter. When the collar, collar starts at 1.2 meters per second. Okay, the collar starts at 1.2 meters per second. Its final velocity is 0 meters per second. The unstretched length of the spring is 0.25 meter. The K is 0.32 kilonewton per meter for the spring. 2 times I wrote 60 Newton, that's just a mistake. The P is 60 Newton, the force by the motor, because you switch on the motor, right? This is a pulley. Pulley has 2 strings. Friction force exerted by these walls and on the counterbalance is 180 Newton. Friction force is 180 Newton. What do I mean by exerted by? I'm sorry. Friction force experienced by the counterbalance is 180 Newton. Do it. Okay. So if you are wondering what exactly you will have to do, I will just help you a little bit. You will say that 60 Newton multiply by the distance, right? From 1 to 2. And that is, I suppose, 0.4 meter plus U12 friction. So what is U12? That is 180 plus or minus. Plus or minus, you will answer this. then distance you will have to answer. So I think students understand that there will be a negative sign here. And if this distance is 0.4 meter, then that will be 9. If this is 0.4, then the counterbalance will go SA plus 2SB equal to 0. And then we have VA equal to negative of 2VB. And then we have AA equal to negative of 2AB. Okay. So when the this 14 kilogram fellow moves SA, then the counterbalance moves half the distance. So I will say if this fellow moves 0.4 meter, counterbalance moves 0.2 meter. Is it clear or not? No? Pulley. You did not practice pulley problems, no?
I need to say that if 14 kg is moving 0.4 times, I mean 0.4 meters, then it should also go 0.4 meters down.
There is a pulley with 2 springs. There is a pulley with 2 springs. We went over pulley problems in this class. Do you remember? No? In pulley problems, we said SA plus 2SB, 2 SA plus 2SB equal to 0. Sure? Okay. Okay, any student who wants to explain the meaning of the negative sign, what does SA equal to negative 2SB means?
Energy loss.
No, I will, no, oh, no, but when I say SA equal to negative 2SB, we used to say, when we used to talk about pulley problem, when this mass is going down,
That's going on.
this mass is going up. But in this particular scenario, when this 14 kilogram is going towards right, the other mass is also going downwards. So why do I say that SA equal to negative 2SB? What is the physical interpretation of it? So I can explain that. What you have to understand is that your reference line, unfortunately, is sitting between the two fellows. Are you getting my point? So if this is my reference line, then this is your what is my A and B, by the way? I suppose this is A, the mass A. Yeah, this is my reference line. This is my SA. And this is my reference line. This is my SB. Do you see the positive sense of SA and SB? Because this is my reference line. And I always used to tell you, whenever you have your reference line between the two fellows, it becomes very confusing. This is what is happening actually. So actually, when SA is going towards the reference line, SB is going away from the reference line. So that's why this SA is coming out to be negative 2SB. It doesn't mean that one is moving up, the other is moving down. So if this is going like this, the other is also going like that. No, the negative sign, you should not get confused. Okay. And having said that, you will just finish the problem by saying you want to, by outside and non-conservative forces, you have to give me the value. Okay.
Hocam, is the mass of B is 13.8 kilogram?
I have to see my notes. Okay, let me see my notes. It's 17 in my notes, 17 kilograms. We will, when we go through this, we will see. Okay, U12 comes out to be. Okay, why is that? Do it. Huh? What? -1. Yes, thank you. Okay, so U1, no, he is telling me the U12 answer. So U12 comes out to be -12 Newton meter. Then the next bit is delta T, which is equal to delta T A. This collar is A. The counterbalance is B. Then you have, please, you can call this as A, of course. Okay, then you have 1/2 MA into V2A square minus V1A square, which is equal to plus, I apologize, plus 1/2 MB V2B square. Okay, I'm not doing it, definitely not. Just do it. Give me delta T. You have one student here. You can help us. So give me the delta T quickly. 1.08. I will borrow from someone, but just do it. You got it?
It's 1.08.
The delta T or the answer?
Rather,
Delta T is, okay, he got the answer as 10.1 minus 0.18. Thank you. Okay. So which is equal to whatever it is. Again, Newton meter. Okay. How did I do it? I substituted V2A as 0, I suppose. And I substituted V2B as 0. And I substituted V1A as 1.2. And I substituted VB as VA divided by -2, but the square helps us here. So substitute here, okay? So delta T comes out to be this value. Last but not least, you have delta VE.
Sir, what about the mass of?
yeah, which one means the bonus?
1/2.
No, we don't know MB. That's the thing.
That's the unknown, no? MB is the question mark. Oh, sorry. So
That's not that.
I think I understood your question. I think I forgot. Sorry, 0.18 MB. I apologize. Thank you. Thank you. Very good. Okay. So having said that, we will have B means counterbalance. Delta VE equal to 1/2 K into delta 2 square minus delta 1 square. For students who attended the last class, you remember that we talked about it, but of those of you who have just joined us, let me explain. This is L1 minus L naught. This is your physics formula. Do you remember your physics formula? 1/2 K x2 square minus x1 square. That's pretty much the same thing I have written, just in a different form, because if the spring itself has an unstretched length, and initially if I have already stretched it, right? So that I'm calling it as delta 1. You can call it as x1, as long as you understand what you are doing. Okay. And delta 2 equal to L2 minus L naught. This one is easy because you can all observe that initially when the spring is sitting, how much it is, length is 0.3 square plus 0.2 square, square root of 2. Do it. 0.3 square plus 0.2 square root of 2. I'm sorry, square root. So I will have, how many students agree?
0.36.
Thank you. 0.36 is right. 0.3 square plus 0.2 square. Thank you. And then I will minus 0.25, which is the unstretched length. Why don't you focus here, everyone? Yeah, this one. 0.25. This one. So I will get an answer of 0.111 meter, as one of the students indicated. Now, last but not least, hang in there with me, please. delta 2 will be L2 minus L naught. Now this is tricky, right? Because when the collar goes to the right, what happens to this spring? Focus, it will become like arrive till here, right? Till here. So you will have this big triangle that will have its nice and beautiful base of 0.4 plus 0.3, that is 0.7 meters. Oh, what happened to my paint? Oh, something happened to the paint. Oh, anyways, so this is 0.111. So this becomes delta 2 equal to square root of 0.7 square plus, okay, what will be the height of the big triangle if this becomes here? The height will be still 0.2, but the hypotenuse will be, so it will be 0.7 square plus 0.2 square minus so base square plus something has happened to the paint, by the way. Okay, sorry, minus, oh, come on, minus 0.25 is the unstretched length. So delta 2 becomes, I don't know, anyone?
0.472.
0.48, right?
0.4.
Okay, now students who are getting confused, I will just make two triangles so there are no confusions left. This is your 0.3 and this is your 0.2. And again, students who are getting confused, this is my big 0.7 base and this is again 0.2 meter. Is this clear? No, yes, no? Huh? Yeah, very good question. Look. You see this spring, this one? When this spring is initially sitting, it has a unstretched length of 0.2 meter. So initially, the 14 kilogram collar has already pulled it a little bit. So that's why I have to keep subtracting the L naught from both the fellows. Okay, and everyone, thank you for the patience. The question is big, and we will finish the question by writing delta VE equal to, do the number crunching, 1/2 multiply by 320 Newton per meter. 0.32 kilonewton per meter. Thank you. Multiply by 0.48 square. How many agree with me? 0.48 square minus 0.111 square. And very nice, beautiful answer of 35 Newton meter. Okay. Last but not least, we need to have our how many agree and how many disagree? Delta VG. Oh, come on, where is delta VG? I think I forgot delta VG in while doing it.
Yes.
Okay, let's do delta VG together. Delta VG is equal to, okay, so let's do it together. How much distance, how much height is changing for 14 kilogram? Nothing. But for the counterbalance, the height is changing. So I will write delta VG is equal to MB. Okay. It's just bizarre that I cannot find it from my notes. But anyways. You can tell me MB G times. Okay, 0. Yes, I think it's pretty straightforward. There is no need to worry about it. Now, there is just one trick that you have to remember, that the counterbalance, when the collar goes towards right, the balance goes downwards, right? So the change in potential energy is actually in the negative. So that's the only trick, that when you are writing here, you have to put a negative, and you have to put a, okay, so SB is equal to half of SA. He was absolutely right, but I put a negative here. Huh? Negative means that the potential energy is changing in the negative sense, because the potential energy is definitely decreasing as the counterbalance is going downwards. So that's why I put a negative. Okay, I think we have all the, what happened? Nice and beautiful chunks. So now I will put the final part, U12 outside non-conservative is equal to, sum all of them together, MBG negative 0.2, and then I have by the way, 9.8 multiplied by 0.2 gives me 1.96, right? I think so. Okay, then I have delta T term, and I will go up. That is 10.1 minus 0.18, 10.1 minus. Oh, there's a, I think here I made a mistake. This is half MA V2 square minus V1 square. So I think there is another negative sign here, probably. So I will have negative 10.1 minus 0.18 MB, and then I will put the brackets, and then I have plus this chunk delta VG, plus for delta VE, I will see my delta V is 35 Newton meter. From here, my MB comes out to be, now this left hand side, I will scroll up the screen. It gives me negative 12, if you remember. So I will say negative 12 Nm equal to the complete chunk. I hope that this is clear. Plus MB G into negative 0.2 plus 35. So MB comes out to be 17, nahin? Yes. Any remarks? No. Very big problem. Was it confusing? No. It was just too many steps, but it's clear. You have to find U12. That's because of external force. That's because of non-conservative. It is equal to the change in gravitational potential energy. If the mass has a decrease in gravitational potential energy, then you have to put a negative sign there. If there's an increase in gravitational potential energy, there will be a plus sign. Confusing? Clear? Comments? No? Okay, so I'm stopping here for 30 seconds. Have a look. Ask me questions. Okay. On that note, since it is clear to everyone, hopefully. Should I do what? Here. Okay. We will do another problem quickly. This problem is going to be done by you. Okay. So do this problem, please. Quickly. So again, the problem is straightforward. Let me make some adjustments. Okay, so the problem says, hang on. Let me think about it. The problem says that the mass is with a spring. Initially, it is stationary. Now, 8-pound force, somebody had been holding it, somebody removed their hand, so the mass started its motion towards right. Now I am telling you all of this because if I had told you that somebody gives a push to the A, then that would have meant that there is an initial velocity. What I'm saying is somebody just dropped their hands from 8-pound force, so the mass A casually goes towards right. The question says that you have to give me V when velocity when x is equal to 4 inches. 2 dash means 4 inches. And initially the masses are stationary. Initially masses are stationary. Okay. Why don't you try? I know the variation is about to start, but let's do this. So, what will be the first step? You will say U outside non-conservative is equal to the 3 chunks on the right hand side. Write the formula U O and C equal to okay, now go step by step. Do you see any external force on this system? Do you see any external force on this system? But I don't see it. Nobody has applied any force on the system. So the left hand side, hang on. Do you see any friction that is given to me? Any non-conservative? No. So this whole left hand side will go to 0 actually. So 0 is equal to the 3 bits on the right. Are you following me? Did you listen to me what I just said? There is no outside force. Nobody is saying that I am pulling the mass to the A. Nobody is saying about any external force. That's why I keep on saying O means outside force. Did I talk about any friction? No friction. So when I write the formula, okay, U O N C equal to delta T plus delta VE plus delta VG.
The gravity constant was 32.2, right?
32.2, very good.
And its unit was pounds per square.
Meter per second, pound per feet. Meter per second square, so it is 32.2. No, feet per.
So we have to divide this by 12 to get the inch per square, right? Second square. Because they are making a calculation, if they are making a calculation each.
Oh, so you will have to multiply this feet with 12 if everything is in inches. Hey, hang on. I just need to explain something. Don't convert everything into inches because your problem will become very complicated. Keep everything in feet. This is my intuitive guess, but let me double check my notes. Put everything in feet. Okay, anyways. There is another comment because I think you are already doing this problem. So I have to explain one more part to you. Please remember that this 8 pound that is given to you, I have to explain this. Look, all of you are not very used to these systems, so you will get confused. This is the F I am writing for your help. Okay, so this is the weight. Okay, this is weight. So if you want to convert this to mass, you will have to divide it by 32.2 because you are already doing the problem. That's why I'm telling you. Otherwise, I would have started the problem, but it's good that you are doing yourself. So if you want to calculate the mass of this, you have to divide it by 32.2. British system is a little confusing, but with practice, you get these things.
So we don't need to do it. We can just say 8 times 0.4 divided by 12 to get F times X, which is energy, which is equal to the potential.
Huh? If
It's the same thing.
no, if what I'm saying is somewhere in the gravitational potential energy formula, you might need MB, the mass of the
Yeah,
fellow
but
B. But my
MB
point is that
times
this
G
8 pound.
force, which is equal to the 8 pounds, right? So we don't really need to divide 8 by 32.2, then multiply by 32.
Oh, acha. So mg, yeah, sorry. Good. You are right. Okay, everyone. So he's right actually. So 0 is equal to delta T. And delta T has two components now. So delta T is equal to delta TA plus delta TB. What is delta TA? It is half MA. Yeah, I think this is what I meant. Here you will definitely need masses, right? V2A square minus V1A square plus half MB V2B square minus V1B square, which is equal to half 4. This is again 4 pound force, okay? Half 4 divided by, this is why I keep on telling you that in an exam setting, I will not give you English system of units because most of you are not comfortable with it. A lot of practice is required.
Wait, Hojam, is that W weight? Is that the weight of the mass?
That's what I'm saying. That's why I put a little F. These are pound forces.
Okay.
I know that you are confused. Look, this is the strange part about English system. Pound mass and pound force, they all write it with LB. So then how would you know that this is pound mass or pound force? Actually, with practice, with the kind of subjects, we have an understanding. So I actually have an understanding myself. It was only LB written, but I know that this is actually pound force given. But in many academic books, they have started putting, or they usually put subscript F or subscript M, so that students don't get confused. So we have V2A is unknown to me, I suppose. What is the question, by the way? Did I? Oh, the question is find X max. I think I forgot to ask you the question.
No,
You
this is
answered
asking
V.
about V.
B question.
Velocity is unknown.
But X is given.
Acha, sorry. Sorry. Okay. So there are two parts to the question. One is find the velocity when X is 4 inches. The second part of the question is find the X max. So X max means that the A goes like T and it stops at one point. So how much it goes to the right is the second part to the question. Anyways, so I have V2 square minus plus half MB is, I suppose, 8 over into V2B is, I suppose, unknown. How many agree? Minus 0. So delta T is 0.186 V2 square. Agreed. 0.186 V2 square foot pound. Because V2A is, I think, equal to V2B, right? Huh?
They travel the same, because they are connected, they travel the same.
Why did you divide 4 by 22.2?
To get the mass.
But we have the mass, right?
Right. That's why I wrote F. That's pound force.
That's weight, bro.
That's weight. And that's why the system is confusing. That's why I specifically put an F. If I had put a M, LVM, that would have indicated pound mass. Okay. What were you
Sir,
asking?
we were discussing the answer.
Sure, okay. Then we have delta VG is MAG delta H plus MBG delta H which is equal to 0 plus 8 divided by 32.2 pound, nahi, meter per second square, feet per meter per second square. Okay. Okay. Did I do it right?
They're gonna cancel.
Oh. That's why I think he mentioned the same thing. I forgot. So it is 8 mg multiplied by delta H is, I think, unknown.
No, it's no. It's
4
4
inches. Okay, 4 by 12, he's right. And here mg is 4,
8/3.
pound force, sorry, pound force, right?
Well, how's it 4/12 with that? Okay.
Oh, because he also mentioned that x is 4 inches. So if this moves 4 inches, this drops 4 inches. Delta VG.
2.67.
And what did you say? Ask me question.
We were discussing how to calculate the extensions for the neck.
Okay. When I arrive there, we will talk about it. So we will have minus 2.66 pound feet. Boom. Okay, last but not least, but what they are discussing, how to find delta VE. It will be 1/2 K delta 2 square minus delta 1 square, which is equal to 1/2 72 pound per feet into delta 2 square. Now delta 2 square is that's a little confusing. So I think this is 18, and then I will have a hypotenuse, then I will have a base of 4. So I suppose 18 square plus 4 square square root minus, it will become very crazy if I write everything here. So I will not make that mistake. Delta 2 equal to 18 square plus 4 square square root of 2,
18.44.
which is equal to 18.44 minus 12, which is equal to,
6.44.
very nice, thank you. You made my life easy, 6.44, and I will put a square, I suppose. Then I will have, yes, please.
His lengths are in inches and not feet.
So we will have to,
divide it first.
we will have to divide it. Good. But I will divide it later. nahin? So good remark. Excellent. Minus, I suppose,
18 minus 12, which is 6.
18 minus, and how did he figure? Because 18 is the stretch length, L naught is 12. Again, an excellent remark from one of our students. So I will put delta 1 equal to 18 minus 6 equal to 6 inches. Thank you. And then, as one of the students said, why don't you divide everything with a?
But then that's already been.
Nahi. I'm dividing them with 144.
Okay.
So divided by 144, as one of the students told us. Okay. So the whole thing comes out to be, can anyone tell me the final answer for this delta VE? Okay, so
1.36.
good. Very good. Both of you are correct. 1.36 or 37. 1.37? Okay, I will write, as one of the students helped us. Both the students helped us. And then finish the question. So we will have now delta 0 equal to 1.37 foot-pound, that's the delta VE. Delta VG is minus 2.66. Pound-feet, foot-pound or pound-feet, whatever. And delta T, I've already forgot, 0.186 V2 square. V2 comes out to be 2.64 feet per second. Is it clear to Ghazal and Bahadur? And what about, are you following? No. Do you want me to repeat? No? Huh? That this one divided by 12, which one?
4 divided by 12, delta H on.
Yes, very good. So for example, the question says that this mass moves 4 inches to the right. My point is that the mass B will also move 4 inches downwards.
But isn't the formula H2 minus H1? Why do we have division
That,
as an operation? That's the thing.
which one?
Why do you divide 4 by 12? That's the thing, because
Converting
the-
inches from feet.
I'm converting inches to feet.
1 feet has 12, so you just.
I'm converting inches to feet.
Ah,
Let me,
Alright,
no,
alright,
let me answer your question. Your question was, why are we dividing by 12 or why are we considering 4?
No.
So because the 4 inches I had to divide it by 12
I
because,
thought you divided by 12 because the initial length is 12 as well, so I was confused.
oh no, initial length of 12 has nothing to do with this particular operation. Okay, so on that note, final question is find X max. So what you have to say is for X max, I will have V2A equal to 0, V2B equal to 0. So I will have U12, O means outside forces, non-conservative forces equal to delta T, which is 0, plus delta VG plus delta VE. So I will say it is equal to X max comes out to be 0.618 feet. You can double check yourself. That's the nice and beautiful answer. So because this will be a function of X max, this will be a function of X max. You can do it yourself.
Can't we just say that the force is equal to K times delta X, and the force that's applying is X pound force. So we know the K, we can get the X. Because there's no friction to By the way, the answer comes out something different. It comes out 4 divided by 3 inches.
Look, what you have to understand is you said, can't we do MA equal to KX? This is what you just said, right? The problem with that assumption is that the spring's angle keeps on changing. So for example, if I have to do, we will do Newton's law questions a lot, by the way. Right now, I'm not doing, in fact, I have prepared 2 problems today, and then we have a huge chunk of the rigid body kinetics that I will be doing with that. But I need to answer your question right now. Summation of forces is equal to MA, right? Now in the summation of forces, you have to put a negative K delta X equal to MA, right? Now the problem with this is that, 1 minute, this fellow, if I make a free body diagram, my MA for this object is directed towards right. Whereas if you hang on. See, at any particular point, the friction force, as it keeps moving towards right, the friction force angle keeps on changing. Huh? No, friction nahi. Sorry, spring force. The spring force angle keeps on changing. So for example, the spring is pulling it. There is only a projection of the spring force that is pulling it back. As the mass keeps on going towards right, the spring force, the component of spring force that is along MA also keeps on changing. No, you're not getting you get my point. So if the spring has been like this in this direction and mass goes like T in the same direction, you say Kx equal to Ma, I don't have any issues with that. But now as the mass goes towards right, the spring goes so at every instant, the spring force angle also keeps on changing. So this is not as simple as you just said. Why don't we do summation of forces equal to Ma? Are you sure? Okay.
Hocam, can I ask something?
Why not?
You know the equation that we use for, I don't know what that symbol is called, but the one that has notation 1, 18 minus 6.
18 minus 6 is equal to?
So where did the 6 come from? The initial length is 12. Isn't that L1 minus L0?
18 minus 12, I think I wanted to say. This one?
Yes.
I think I needed to write 12. You can double check. It's 12, right? So I think I hurriedly put 6 here. I apologize. Okay. On that note, I think we are done with the question. So, do you want me to repeat this? Is it fine? No, not many of you are asking any questions today. Okay. Okay, on that note, we will do another technique. You want a break or not?
Yes, we're done.
Okay, I actually don't need a break because I already have the schematic today. Okay, everyone, break?
Yes.
Okay then. Let's meet at 11:36 or okay, you want a 10-minute break or 5 minutes? Huh? Who said that? Let's meet at 11:40, okay? It's 32 right now on my clock. Oh, yeah, okay. So you are TEO Tuman, right?
Yes.
Tuman. So let me pause the recording and I will tell you yes, don't worry. I think we can start to write few things. Okay. So immediately when we go into rigid body kinetics, you will see that you will not even sometimes feel the difference because the concepts are similar, but of course they become a little more complicated. But we will talk about very practical problems, don't worry. And okay, the question says, let me at least write the question for you. Find, I have to solve a couple of these because these are very interesting problems. Find AA and AB. So what is the solution? Let us proceed with this problem very methodically. Oh, what the hell? Okay. Okay. Find the solution. Okay. Find the solution. So how to proceed? This is a nice problem. There is no friction. I corrected the mistake. No, this is last semester. So in order to do this problem, I have to come up with the approach. And my approach will be Newton's law in this problem. Free body diagram I have calculated. We still have 1 minute for our students to come. It is equal to 2xa plus 3xb plus and you will see why this is very important.
I need to stop otherwise.
Okay, 11:40 is what we discussed, right? Now I can start. So the first thing that you have to do in this problem is to make a free body diagram for both the objects. The free body diagram I already made, by the way, this one. And now I will make it for the other mass. For the other mass, once you make a free body diagram, you will observe that you have this object that has three nice and beautiful tensions that are acting on it. Are you following me? And now I will have a T, 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 correct? The other one will be the mg. This is mg that is acting. If you make this, then it will become very clear to you. So this is T, T, T. Now, all you have to do in this problem is, because this is the tricky one, there is a normal force because of the surface. There is mg, and then we have two of these wires that are giving a tension. Now, the first thing I will do is I will write summation forces for the object A is equal to m a x a double dot. Now, let me tell you something. There is a comment that I want to make. Without getting into details at this point, it is very important that you already understand in which direction the whole dynamical system is moving. Now, you can perform a quick analysis and it will immediately tell you. I don't have a calculator, but you can help me in that. Look, this is 30 kilograms, right? So minus 30 sine of 20 plus 2t equal to, now I know that you will be like, it's equal to something. Let me actually equal it to a zero. I know that you don't, now I know it's not zero, but I will tell you what something I'm trying to do. You just give me a value of 30 sine 20. I will tell you why. 30 sine 20.
It's bigger than 10, so it's moving downwards.
Ah, good. He already understood what I'm saying. 30 sine 20 is 27 point something now. So if it is 27 point something, then that means 13 point something here, 13 point something here, that is around 27. And this 27 is definitely greater than 10.
30 sine 20 is coming 10.26. 30 sine 20.
Up to the minus 20.
All right, plus 2p. And what's the
Okay, 30 sine 20, just give me 30 sine 20.
10.26.
Are you sure?
Yes.
Did you use radians or?
Why I will use radians for
Means sine 20 in any case is very less. It is less than. So 10.26 is fine now. So yeah, so I think both of you are fine. 30 multiplied by sine 20 gives me 10.2. Now 10.2 in any case is greater than 10. My point is that this object will be sliding downward. Are you getting my point? Both of you, all four of you. Okay. Now, when it is sliding downward, this will actually come into the use later. When you are writing this, you will write summation FA equal to MA X double dot. And you can see that if this is your reference line, then your XA in any case is positive in this direction. So no need to now do anything special here. Just follow the pattern that summation FA equal to MA X double dot. And you can also write here that this is my positive direction. Why this is my positive direction? Because this is how my reference line is. And this is my positive XA. For those of you who are saying, but why did you tell us that this is moving downward? I will explain to you after 2 minutes the importance of it. Now you will write here minus 2t plus MAG sine 20, right? Okay, equal to MA X double dot. Do we have anyone who did not understand this? I can explain why I did mg sine 20. This is mg. This is mg cosine 20. This is mg sine 20. This one is mg sine 20. This is mg sine 20 component along the tension. Now this I will call it as my equation number, equation 1, 2 or 3. Let me call it 3 because I want to remain consistent with my notes, because if I get stuck somewhere. Now, the other equation that I genuinely need today is the summation of forces for the mass B is equal to MB XB double dot. Now, please remember that we already made this calculation that this definitely is going down towards left. Surely this fellow will go up. So I will say that this, according to my reference, is the positive direction, because for those of you who are saying how are you saying this, because your reference is between the two fellows. So this is my positive. Again, this is my positive, because your reference line for the pulley by which you are saying that this is my XB and this is my XA, you can see that beautiful arrow. So that's why you will say that my positive sense is defined like this. And unfortunately, your mass is going up. That's why I will put a negative sign here. That unfortunately, my mass is going up. And why did I put a negative? Because XB is defined positive from this reference line. Now, when it is going up, for sure, you make a free body diagram. There are 3T minus MBG. Now, honestly, from a personal perspective, I hate this kind of approach. I never ever put negative sign in the MA. I usually keep my MAs as positive, and then I always focus on the left 100% of the times, always in my life. But unfortunately, I have to do this because unfortunately, my reference is defined from there, and the mass 100% I know is going up. So that's fine. I will call this as my equation number 2, let's say. And last but not least is my last equation. I wrote this. I will repeat that L equal to 2XA plus 3XB plus C, and DL by DT equal to 0, and that will give me
2AA is the
Ah.
2x double dot is equal to 3 minus 3.
very nice. 2 for all our students. I will just repeat this. 2AA plus 3AB equal to 0, and we will have 2AA equal to -3, 2AA equal to -3AB, and I will call this as my equation number 1, let's say. So how many equations I have? 3 equations. My AA is unknown, I think. AB is unknown, and tension is unknown. So this problem may look simple to you. This is not a simple problem. Trust me, the concept will keep on piling up. This is not a simple problem. If you want to get the right answer, this is not a simple problem. Trust me. I will again emphasize on one thing. I really dislike what we did in the equation 2. Never ever I put negative signs in my MA. You have always in your physics said summation of forces is equal to MA. This is what you have always said, right? Have you ever said negative MA? No, you say MA. And then you play with the left hand side. You don't play with the right hand side. Here I have to make this choice because my reference line for the two masses is that thing that is sitting right at the center. So my XA is defined positive from that, right? Look at the XA, the arrow is towards that mass. And look at the arrow for XB. Again, it is pointing downwards. So the center fellow is my reference. So I had to make that brutal choice that this is how my reference is. Unfortunately, the mass A is moving upward because I performed that static analysis in front of you. We did a 10 sin 20 and both of you did that. No, 30 sin 20, sorry. Clear? What is your name? Hashir. We have Hashir, we have Ahmed, we have Abdullah, and you are?
Hamza.
Hamza. And you are? Oh yeah, I know. Since both of all four of you understand this, why don't you do one more thing? I told you this is not easy. Let me make it more complicated. So, suddenly the concept will become very complicated. And you will say, no, it has not become complicated because you are showing us a similar problem. And I will tell you, no, this is not simple. One minute. In rigid body kinetics, we will be using these concepts a lot. Okay, now let me remove the solution. For those of you who are wondering, from where did I give you this example? This is Merriam reference book. Let me pause it. Where is the Merriam reference book? For the recording. Okay.
Can't we just want the force that is acting on A and then multiply the 20 feet and then get the work done that is onto the A and then using that work done, changing the in the kinetic energy and then the velocity.
Exactly. So you want to do this problem with the work energy principle. Last semester, exactly one student like you said the same thing. And I think he was able to do it. You have to do it like that. Exactly. You want to outside non-conservative. You don't have any outside forces here. You do have a non-conservative force in the form of friction here. So you can have a component. You can calculate the friction force, put it there, change in the gravitational potential energy, do it, and you can really crack the problem. I agree with you.
Is there another easy way?
So we will do it with the Newton's law because I really want to teach you all the 3-4 methods. The Newton's law, the impulse momentum, the work energy. The fourth one I forgot. 3 or 4 methods, whatever. So right now we are at Newton's law, but surely you can do it with work energy. But Newton's law will be extensively used in your rigid body. In fact, work energy as well, but I have to cover everything. Okay, so here's the trick. First of all, what you have to understand is how this object behaves. So this system behaves, any remarks? So do the same thing with me, don't you want to do it?
This system goes down.
Okay, one of the students has already told us that it will go down. I kind of agree. So we have, let us do it together. 2 T equal to 0.5 N I will make the free body diagram. Please give me 1 minute. Plus 400 sine 30. Okay, and T comes out to be, I will explain this to students, 186.5 pounds.
But hocam, the friction force isn't 0.5 Newton. The friction coefficient is 0.5.
Normal, normal. This is not Newton. If I said normal, then I definitely apologize. This is normal force. Okay, this is normal force. Normal force. Please remember, this is not Newton. Okay. Okay. So we have 2t equal to 0.5 multiplied by normal force plus 400 sine 30. And I know that all of you are wondering how did I do it. I will explain later, which is less than the 250-pound weight, which is definitely less than. So if this is tension that you have calculated using this fellow, because the tension is the tension, this is T and this is 2T, then tension going up is 186.5 pound. Log will move up. Oh, I made a mistake, sorry. Log will move up. Log will move up. It will go up. Sorry. Yes. The log will go like this, because if 186.5 is less than 250, then this will go down and this system will go up. Yeah. So our initial calculation tells us that the system will be going like in this direction, moving up, and this fellow will be going down. Now there are students who are getting confused by all of this. I will explain it again. Let me make free body diagrams. I intentionally skipped the initial part because I wanted to determine how the system is moving. Now I can help you step by step. So let's start this problem from the beginning, okay? This is the log. And we have, this is our, let's say, XY coordinate system, whatever, Y or X, or you can make your own coordinate system. This is our free body diagram. There is a 2T here, right? Because of the two strings. And then we have normal force that is acting perpendicular to the surface. We already know that, right? Then we have a 0.5 N. This is why I am telling you all of this. Look, please try to understand this thing. This is 0.5 N. Here comes the $1 million question. Is the friction acting in this direction or that? You cannot make an intuitive guess, because until and unless you do not know whether the log is going up or the log is going down, you cannot talk about the direction of the friction force. The friction force acts opposite to the direction of the motion. Now, if you already know that the log is going up, then you can say that the friction will be down. This is why I first of all made some quick calculations just to have an idea. I hope this part is clear. Now I will put the 400-pound force right through the, yes, please.
Now, shouldn't it be 3T because there's 2 wires above C and 1 below C?
No. There is 2. I will explain. Just give me 1 second. Good question, but I will answer this like this. Good question. Look, there are not, this is 2 only. These are not 1 plus 2 plus 1. This is 2. Okay.
So the 2 is pulling.
2 is pulling, right? You can reduce this, put this right next to it. Doesn't matter. These are 2. Okay. Now that you have got this, you need one more free body diagram for the block A. This is my beautiful block A. There is 250 pound here. And there is attention. Now I will repeat again, because there are many students who are getting confused. How did you figure that this is going up? For all of the students, I will do. And now with the free body diagram, I will do one more time. 2T equal to, let's say, 2t equal to 400 sine of 30. Okay. Let's say plus 0.5 n. Now, what is 400 sine 30? 400 sine 30 is
200.
400 sine 30, 200, and t equal to 100. T is 100. Okay. T is 100. Now, even without the friction, you see that T comes out to be, you told me T comes out to be 100, right?
180. Without-
Without friction, it comes out to 100. So without friction, if this is 100, and this is 250, then the block A will go down, right? And the log will go up. Are you getting my point? So without friction, you can have an estimate very quickly. So you will understand that this is how the system behaves. And now that you have an idea, you can actually put the friction force. Okay, but I will. I apologize. I said without friction. So if there is no friction, I still have okay, 2t. No, sorry. Okay. Good. So without friction, I get 100. So I have determined that the block is going up and this block is going down. Now that I have a clear idea, I put the arrow downwards. Okay. Now that I understand this, that the direction of this 0.5 n will be in this direction, I can continue with the problem. And let's do it together. So now we determined that that 0.5 n will be acting in this direction. Okay. Now let's do summation of forces in the y direction equal to 0 for the block. Yes, please.
It's not Newton, it's normal force.
That's normal force. 0.5 multiplied by n, that's normal force. That's not Newton. Yeah, so summation of forces in the y direction equal to 0. So I will have, let's do it together with me, please. I will have positive n minus 400 cosine 30 equal to 0. Positive n minus 400 cosine 30. Is it clear? Even if some student is not sure how did I do a plus n minus 400 cosine 30, you can ask me. Don't hesitate. No? Anyone? Okay. Okay, now, anyways. Okay. Then we have n equal to, n comes out to be 400 cosine 30 gives us 346. And when n comes out to be 346, I'm not even sure why on earth even did I have the need of doing it without friction. So in fact, I think with one step, I could have used it here and would have immediately got that T comes out to be 183 pound, right? So 186.5. So I'm sorry, I am changing it again and again, but of course with friction. And from here, I arrived at the conclusion that a log is going up and that fellow is going down. No need to do it without friction. I was just saving my own time. Sorry. Now that I have got n equal to 346, you can actually proceed by solving the rest of the problem. So summation of forces in the x direction equal to 0. Now just imagine that your log is going up. That's why the friction is acting downward. But where is my reference? Fortunately or unfortunately, my reference is sitting between these two. So this is my reference. This is my x of A. And this is my, again, x of, oh, I apologize. I mean x of B. And this is my x of A. So if this is my reference lines, I will just finish the problem as summation of forces in the x direction. I will copy this chunk, Control V. So this comes out to be, hang on with me, please. 400. It's cosine 30, 400 sine 30. And I will put a positive sign here. And then I have plus 0.5 into normal force, which I got as 346. And then I have the tension going towards right. So summation of forces is equal to not 0. I apologize. It is equal to MAX. So it is equal to M multiplied by AX, and this is my mass C. Oh, I think if you look at the diagram, we already have a B here. This is A. So let's call, oh, we have a C. So let's call this log, or this is already C. So let's call it C. It is equal to MAC. Now, for those of you who are saying, why did you define your X here? I already told you quite a few times that your XC is defined from the reference, which is somewhere here. Now, we will just finish the problem by doing the last bit, that is summation of forces is equal to MA. This time for the second fellow, which is this one. Please bear with me. And this is Control V. And again, I already told you that the block V is going downward. So I will say if it is going downward, then it is equal to MAAA. And then I will put summation of forces as negative tension plus 250 pound force is equal to MAAA. Yeah, pound forces. I told you with a lot of practice of books, you will understand a feeling. The textbook never told me, but I know this is pound force. Okay. Okay. Now I will finish the question by writing MAAA. Now MA is minus T plus 250 pound force is equal to 250 divided by 32.2 AA. So now let's name the equations as 3. Then name this as equation 2. And then let's name this as, please bear with me and give me 1 minute, please. I will. Okay. Now I will leave it here for our students to copy. C was the log. I apologize. C is the log. A is the mass. B is a point below mass A. C is the log. Okay. You see this one, this pulley. This pulley is C. So you can call this as C or the log as C. It's the same thing.
So for the first equation that you made,
Huh?
if we say that the log is moving upward,
Nee, ek minute. Which equation are you talking about?
the first equation for MA.
Uh,
MA.
N minus 400 cosine 30. Okay.
No, sir, this one, 400 sine 30 plus 0.5
Is equal to 2t.
equal to minus 2t equals MA. Sir,
Are you talking about this
this
two?
one written in black?
The second.
Second equation.
Yeah, this one.
This one?
Yes.
400 sine 30 plus 0.5 minus 2t. Huh?
But if I say that the log is moving upward, it means that the tension should be greater than the downward forces acting. Shouldn't it be 2t minus 400 sine 30 minus 0.4346 equals MA?
Okay, I will explain how. Look, what you have to understand is that this is a whole, this is why this problem is very confusing. I will tell you why. Your approach might work, but at the end of the day, there is another problem to it. Your approach cannot work. I will explain why. There is one more equation that I need, I think. Then I will answer your question. Your question is very good. Did I miss any equation? I think there is one equation I missed. It is the relation between AC and AA. Then I will answer your question. So you have to bear with me. One more equation is, and then I will answer Abdullah's question. Look, this is 2AC. Are you following me? And this is AA. So the another equation is AA plus 2AC equal to 0. That's the equation 4. So 4 equations, and then you can have 4 unknowns.
Hocam, in equation 2, I guess the net force is equal to 0.
Which
So
one?
we might have to found the tension as a wrong value.
Where? Nee, hang on. You're not getting my point. This one is not a separate equation. Did I name it as a separate? No. You see this chunk, I have to remove it. Control C.
yeah, that was
I keep on saying the same thing, that this I had to do to determine how the system will move. This tension value is wrong. I am not going to use this tension value. You have tension as the unknown. This is a static analysis part. Oh, come on. I am so sorry that I should not have written this. This is static analysis part that I did to determine how the dynamical system is behaving. So static analysis, this is not the value of tension. Oh, I have to write it here. Tension value here is wrong. Now I will answer Abdullah's question. Here is wrong.
Can you please also explain the equation acceleration of A plus 2 times?
Yes, I will explain that. Now let me go step by step. Your first question was about the equation written in the black font. The answer to your question is that you have already determined how the dynamical system is moving and your reference line. Look, your reference, come on, your reference is from here. Okay. So if your reference line is this one, then MAC is supposed to be positive in this direction. You are already saying that the block is going in that direction. Right. So now I wrote, yeah. So that's why I wrote this, that negative 2t, where is it? Negative 2t, because my positive sense is defined here. Okay, negative 2t. This is my positive sense for MAC. So negative 2t and positive sense of MAC is like this. And I wrote the whole equation. Okay. Now, last but not least, I have to explain AA plus 2AC equal to 0. Well, that is easy because the total length of the rope is if you remember, it is equal to 2 xc plus xa. So your L is equal to 2xc or SC if you want to call it, whatever, plus XA. So this is how you got AA equal to negative 2 AC. AA equal to negative 2 AC. Okay. Yes.
Can we explain this or
Huh?
can you explain this or
Third equation. So the third equation is third equation is this one. So this mass is 250 pound force. The weight is acting downward, and the tension is acting upward. So I did 250 minus this thing. Now this whole object is going downward, right? And there is another catch to it, that in any case, my MA is, so for example, my acceleration AA is defined positive in this direction. So I just did a negative T plus 250 equal to MA. Because the tension is acting upward, the weight is acting downward, and the MA is defined positive downward, because my reference line for AA is this one. And just to be clear on one thing, there are a lot of students right now who are thinking like this. I will finish this question on this remark. They are saying that you wrote a MSc here, and then they are also saying that, look, the AC is going up, right? And your positive direction is this. How can you write it MAC when it is acting up? The answer to this question is that, do you see this AA equal to negative 2AC? This will automatically correct the direction. So this is why I'm not playing with this. I'm not writing it as AA equal to 2AC. I have to follow the method. So AA equal to negative 2AC. It will make sure that all these equations will solve themselves correctly. You need a lot of practice for this, just to be clear. I tried my best that I explained the methodology, but you have to open the Merriam or Hibner book. Okay. I hope it is clear. Four equations, four unknowns. Right?
3 unknowns. But tension, acceleration, A, acceleration C. Normal force, we already found that.
Okay. Okay, so normal force we already found. So 3 equations, 3 unknowns. Okay, but I keep on saying that static analysis, the tension value here is wrong. Of course, I have mentioned this. Okay. So we have okay. Okay, I think we have 10-15 minutes, so we can do one more thing. Let's talk about very quickly planar curvilinear coordinates, because when you are coming from your Eid vacation, you do realize that your midterm 2 is right around the corner, right? So planar curvilinear coordinates. I will make sure that I provide you as many helping files as possible, so you are all ready for your midterm 2. Now you do realize that we have summation fx equal to mx double dot. Then you also realize that your summation fy equal to my double dot. Then you also realize that Oh, what happened to my teaching pad? Huh. Anyways, so you realize that this is what is known, you have to use Cartesian kinematics to get hold of the fellows on the right hand side, let's say, and proceed. Now, please remember that if you in a planar curvilinear coordinate start using them, it will become a little hard for you. Okay, so we use what is known as normal tangential coordinates. Normal tangential coordinates. And for normal tangential coordinates, summation of forces in the normal direction is equal to MAN, and summation of forces in the tangential direction is equal to MAT. Now there is one more thing, not sure if everyone remembers this, which is our favorite formula, summation FR equal to MAR, summation of forces in the radial direction is equal to mass multiplied by acceleration of the object in the radial direction. The summation of the forces in the theta direction is equal to mass multiplied by acceleration of the object in the theta direction, where AR is equal to
Which one, theta direction?
in the theta direction, what?
What do you mean by theta direction?
Angular direction, theta
So it's
direction.
Alpha, right? When we say a theta, it's alpha.
No.
Angular direction.
Oh, no. Hang on. No. Okay, I will explain. I will answer your question. Good. And I will also revise this. So AR is R double dot minus R theta dot square. And acceleration in the theta coordinate is R theta double dot plus 2R dot theta dot. This is alpha.
So it's Coriolis acceleration.
Good.
Times the, yeah, I get it. Oh, okay.
Good. So you have to remember this, that the big acceleration formula that you studied, it had tangential acceleration R alpha, it had R omega square, that is normal acceleration component, it had Coriolis acceleration component, and it had the relative acceleration term, that is R double dot. So still, if it confuses you, I will just make very quick system here.
No, I get it.
Got it?
No,
So this is theta coordinate. When I say theta direction, I mean this one. And when I say radial direction, I mean this one. Okay. Angular direction is theta direction. This is what is known as polar coordinate system. Okay. So we will do a couple of problems. 12:22. I'm not even sure in 8 minutes can we even do it. I will do it. So 6, 5, 4, 3, 2, 1. Should I continue? Okay. So the problem says that we have, let's say, an aircraft. So look, you have an aircraft that is flying, and you do know that there is a banking angle, right? There's a banking angle, and you can even talk about this whole thing with the motorbike as well. You have to tilt it to turn it. So it's not like we have to get in a fighter plane to understand this. From the top view, I have this object, and this is an airplane. So why don't all of you open the Merriam reference book and go through these pulley kinetics problems yourself, because I'm scared that it is not 100% clear. So the aircraft is going in this direction, and this is my, let's say, center of mass, for example, whatever. This is my normal direction. Normal direction is pointed towards the center of curvature. Everyone understands this, right? The question says that the velocity is 400 miles per hour. And the question says that the radius of curvature, so this plane is taking a big round, and the radius of curvature is 587. I'm sorry, the radius of curvature is 2 miles, okay? 2 miles, that's just huge, by the way. And it is equal to 500 and uh, 87 feet per second. You have to double check whether this is 1 mile or 1 mile per hour. Why don't you convert 400 miles per hour to feet per second on your calculator, please? 400 miles per hour to feet per second. I think this is 1 mile per hour. But you can double check. So 400 mile per hour in Google to feet per second. Okay. Now the question says that if it is flying
586.7.
1 mile per hour.
Yeah.
Excuse me. Okay, ठीक है. Oh, okay, thank you. If it is flying,
No, I'm telling 400 miles per hour is equals to 586.7.
so this is 400.
Yes.
Okay, thank you.
1 mile is 1.47.
Okay. My mistake. 400 mile per hour. Thank you. If it is flying at a constant speed, then find the banking angle. Okay. For it to remain in the circular path. Now, this question becomes very confusing if you do not make the right diagram. From here, what on earth do you even mean by a banking angle? For you to see a banking angle, you have to get behind the plane, right? And then see it make a banking. From the top, how on earth can you see a banking? From the behind the plane, you will see a banking. So you will actually create another coordinate system of z, then another coordinate normal. Are you getting my point? So this is your normal. This is your z. And there are students who are saying, then what on earth is this? Tangential. From the top, I have this as tangential direction, this as normal. But from behind, I see, hang on. See here, if you can have a look here, probably Abdullah. So if you look from behind, there is z and this is normal. From top, that is tangential, that is normal. So from behind, I will make yellow color aircraft. The same aircraft looks like this. Anyone? From behind, it looks like this. No, not this big. It will look very small from behind, and the wings will be at an angle. And this angle is theta. And this is my mg. This is my lift. In this direction, I have lift. This is my weight. Are you getting my point? So you have to bank the plane for it to remain in the circular path. Honestly, if you in an exam setting make these two diagrams, the question is already a game over. Summation of forces in the tangential direction is equal to mat. What is the tangential acceleration? 0, because it's constant velocity in the question. So summation ft equal to 0. Do I get any information from here? No. The thrust produced by the aircraft and the drag it faces, both of them combine together to make sure that it goes in a constant velocity, constant speed. There is nothing I can do with this equation. I have to I have to proceed. The other equation is summation of forces in the normal direction is equal to MAN. What happened? And then I will have this as M V square over rho. And the summation of forces in the normal direction is L lift sine theta. This is my nice and beautiful equation 2. And last but not least, equation number, I need another equation. Summation of forces in the z direction is equal to MAZ. And I can say that L cosine theta, lift multiplied by cosine theta, minus mg equal to 0, right? AZ is 0. This is my equation. Hang on. I know that all of you are like, but how do you know that the plane is not going a little towards in the upward direction? The answer is that I made a mistake of not telling you this. The question also states that the aircraft remains in a horizontal plane. So when you look from behind, like a orange, you slice it horizontally. So the plane is going in a horizontal circular path. It's not going up or down. So that is my mistake. So AZ is genuinely 0 because of the way the question is given to us. Okay. Now I have 3 equations. And all you have to do is play with the equation 2 and 3. So the equation 2 has L sine theta and this has L cosine theta. So I will say L sine theta over L cos theta gives me tan theta equal to mv square over rho divided by mg. Mass of the planes cancel and theta comes out to be yeah, you do it yourself. Tan inverse v square over rho g. G is 32.2. Rho is given to me as 2 miles converted into feet. You get 45.4 degree. So theta equal to tan inverse. Students who look at their notes, 587 square divided by 10,560 multiply by 32.2.
What is 10,560?
The radius of curvature. Radius of curvature is 2 miles, right? So I converted that into feet. That's why I'm writing 587 square over 10,560 multiply by 32.2 feet per second square. Okay. Thank you for the patience, everyone. Okay. Class is over, by the way. Thank you. I appreciate it. Have a nice Eid vacation. I wish you a happy, safe Eid. Okay, ji. Allah Hafiz. Bye bye.
Just thank you for the comments.
Oh yeah. Okay. Bye bye. See you. Okay.